A various digital ICs available in the market belong to various types. These types are known as logic families. What is logic family? Logic family is the type of components used to make logic gates on IC, which stands for integrated circuit. Logic families are groups of logic circuits that based on particular types of elements, which is resistor, transistor, etc. A logic circuit of particular family can be interconnected without having to use additional circuit. Based on the components and devices eternally used, digital logic families are named as RTL, TTL, and DTL. RTL stands for resistor transistor logic. In these types of logic, input signal are applied to resistor and the out is produced by transistor. So RTL normally constructed from discrete components, individual resistor and transistor. Some circuits are manufactured as integrated circuit and packaged in modified transistor outline. The second is TTL. TTL stands for transistor logic. Input signal are applied to DOD. TTL is normally packed in the IPC, which is dual inline package, as in completely common in military equipment. The basic techniques for manufacturing ICs are the bipolar technology, metal oxide semiconductor or MOS technology. The bipolar families is a logic circuits constructed specially from components fabricated bipolar transistor in the chip. In the bipolar category, there are three basic families called diode transistor logic or DTL, transistor logic or TTL, and emitter coupled logic or ECL. DTL uses diodes and transistor. TTL uses transistors almost exclusively, and TTL has become the most popular family in SSI, or stands for small scale integration, and MSI stands for medium scale integration chips, while ECL is the fastest logic family which is used for high speed applications. The second technique is MOS families. It stands for metal oxide semiconductor technology. In the MOS category, there are three logic families, namely PMOS or P-channel MOSFETs families, NMOS or N-channel MOSFET family, and CMOS or complementary MOSFET family. PMOS is the oldest and slowest type. NMOS used for LSI or large-scale integration, failed for microprocessors and memories. CMOS, which uses a push-pull arrangement of N-channel and P-channel MOSFETs, is extensively used where low power consumption is needed, such as in pocket calculators.
Characteristics or parameters of logic families. Even though there are various logic families, the general characteristics, their definitions, nomenclature, and terminologies used for all of them have been standardized. So let us discuss some of the most important general characteristics. Voltage and current parameters. Voltage parameters or threshold levels. Ideally, the input voltage levels of 0 volt and positive 5 volt are called logic 0 and 1 levels respectively. However, practically we will not always obtain voltage levels matching exactly to these values. Therefore, it is necessary to define the worst case input voltages. VIL, the worst case low level input voltage. This is the maximum value of input voltage, which will be considered as a logic 0 level. If the input voltage is higher than VIL, then it will not be treated as a low or 0 input level. VIH, the worst case high level input voltage. This is the minimum value of input voltage, which will be considered as a logic 1 level. If the input voltage is lower than VIH, then it will not be treated as a high or one input level. VOH, the worst case high level output voltage. This is the minimum value of output voltage, which will be considered as a logic 1 level, and if the output voltage is lower than VOH, then it will not be treated as a high or 1 output level. VOL, the worst case low level output voltage. This is the minimum value of output voltage, which will be considered as a logic 0 level. If the input voltage is higher than VOL, then it will not be treated as a low or 0 output level. The voltage parameter can be shown on the digital circuit, consisting of gates as shown in the below figure. Note that the NAND and NOT gates are shown can be of TTL, ECL, CMOS, or any other type. Current parameters. IIL, the low-level input current. It is the current that flows into the input when a low-level input voltage in the specified range is applied. IIH, the high-level input current. It is the current that flows into the input when a high-level input voltage in the specified range is applied. IOL, the low-level output current. It is the current that flows from the output when the output voltage is in the specified low voltage range and specified load is applied. IOH, the high-level output current. It is the current that flows from the output when the output voltage is in the specified high voltage range and specified load is applied. If the output current flows into the output terminal, then it is called a sinking current. And if the output current flows away from the output terminal, then it is called a sourcing current. The current parameters are displayed on the logic circuit shown in the figure below. Note that the actual current directions can be opposite to those shown in the figure, depending on the family. In most data books, the current flowing into nodes or devices is considered as positive, and current flowing out from the node or device is considered as negative. Fun-in. Fun-in is defined as number of inputs a gate has. For example, a 2-input gate will have a fun-in is equal to 2. Fun-out. Fun-out is defined as the maximum number of inputs of the same IC family that a gate can drive without falling outside the specified output voltage limits. Higher fun-out, higher the current supplying capacity of a gate. For example, fun-out of 5 indicates that the gate can drive at the most 5 inputs of the same IC family. The concept of fun-out will be more clear if you refer to the figure given below. As shown in the figure, fun-out of the driver gate, which is driving N, number of gate is N. Fun-out is also called as the loading factor. If the specified fun-out of a gate is 10, then we should not load it with more than 10 gates, because then the output logic level voltages cannot be guaranteed. Fun-out depends on the nature of input device that are connected to an output. unless a different logic family is specified as the load device. Fan-out is assumed to be referred to load device of same family as the driving device.
Noise immunity is defined as the ability of a logic circuit to tolerate the noise without causing any unwanted changes in the output, while noise margin is a measure of design margins to ensure circuits functioning properly within specified conditions. Sources of noise include the operation environment, power supply, electric and magnetic fields, and radiation waves. On-chip transistor switching activity can also generate unwanted noise. To ensure the transistors switch properly under specified noisy conditions, circuits must be designed with specified noise margin. The difference between minimum output high and minimum input high is known as high-level noise margin, and the difference between maximum input low and maximum output low is called the low-level noise margin. Propagation delay is defined as the time delay between the instant of application of an input pulse and the instant of occurrence of the corresponding output pulse. Propagation delay is small in a human scale, often measured in nanoseconds or picoseconds. Each gate must stabilize before the next one in the sequence can be read, so the total time for each gate in the longest possible output sequence is added together to form the total delay. There are two propagation delays. The first one is TPHL, the propagation delay measured when the output makes a transition from high to low state. The next one is TPLH, the propagation delay measured when the output makes a transition from low to high state. The propagation delay should be zero, and practically it should be as short as possible. The values of propagation delays are used as a measure of the relative speed of logic circuits.
Power dissipation. As a result of applied voltage and currents flowing through the logic families, some power will be dissipated in it in the form of heat. The power is in milliwatts. Care should be taken to reduce power dissipation taking place in the logic ICs in order to protect the ICs against damage due to excessive heat, to reduce the loading on power supplies, etc. Another importance of power dissipation is that the product of power dissipation and propagation time is always constant. Therefore, reduced power dissipation may lead to an increase in propagation delay. Operating temperature. The temperature range acceptable for the consumer and industrial applications is 0 degree and 70 degrees Celsius, and that for the military applications is negative 55 degrees to 125 degrees Celsius. The performance of gates will be in the specified limits over these temperature ranges. Figure of merit, speed power product or SPP. The figure of merit of a logical family is the product of power dissipation and propagation delay. It is called the speed power product. The speed is specified in seconds and the power is specified in watts. Practically, the value of figure of merit should be as low as possible. The figure of merit is always a compromise between speed and power dissipation. That means if we try to reduce the propagation delay, then the power dissipation will increase and vice versa. The speed power product is used as a common means for measuring and comparing the overall performance of different IC families. Invalid voltage levels. The operation of a logic circuit will be proper if and only if its input voltage levels are kept outside the invalid voltage range. That means the input voltage should be either lower than VIL or higher than VIH. The invalid input voltage will be produce an unpredictable output response. Therefore, it should be avoided. When the output is overloaded, there's a possibility of output voltage going into an invalid range.